Hello everyone. Today in this lecture we are going to discuss about clustering. Clustering is a powerful, unsupervised learning technique that can uncover hidden patterns and structure within a complex database. By grouping similar data points together, clustering algorithms enable us to gain valuable insights without the need for labeled training data. In this presentation, we will explore the fundamentals of clustering with a focus on widely used K-mean algorithm and demonstrate its practical applications across various domains. First, understanding K-mean clustering. Core concept: K-mean clustering is an iterative algorithm that partitions a dataset into k distinct clusters. The algorithm aims to minimize the sum of squared distances between the data points and their assigned cluster centroids, ensuring that data points with the cluster are as similar as possible. Key steps: initialize k random centroids. 2. Step: assign each data point to nearest centroid. Third, recalculate the centroids based on the assigned value. Repeat the step 2 or 3 until convergence. Preparing data for clustering. First process is data processing. Second is feature selection. Third is dimensionality reduction. First is data pre-processing. Clean and pre-processable the dataset to ensure it is ready for clustering. This may involve handling missing values, scaling features, and identifying relative variable. Second, feature selection. Carefully select the features that will be used in the clustering algorithm. Irrelevant or redundant features can negatively impact the clustering result. Dimensionality reduction. If the dataset has a large number of features, consider applying the dimensionality reduction techniques such as principal component application analysis to simplify the data while preserving the most important information. Implementing K-mean clustering. R implementation and Python implementation. First we see R implementation. In R, you can use the built-in k-means function to perform k-mean clustering. This function takes the dataset and the desired number of cluster as input and then return the cluster assignments and cluster centroids. Python implementation. In Python, you can use the k-means class from the sklearn.cluster module to implement k-mean clustering. This class provides a simple and efficient way to cluster data with options for customizing the algorithm's parameter. Visualizing clustering results. 2D visualization, higher dimension and cluster profiles. In 2D visualizations for datasets with 2 or 3 features, you can create a scatter plot to visualize the clustering results. Each data points can be colored based on its assigned cluster, and the cluster centroids can be displayed as larger markers. Higher dimension. When working with datasets with more than 3 features, you can use the dimensionality reduction technique like PCA or TSNE to project the data onto 2D or 3D space for visualization. Third is cluster profiles. You can also create detailed cluster profile by analyzing the characteristics of data points within each cluster. This involves computing summary statistics, visualizing cluster specific distribution, or identifying the most influential features for each cluster. Determining the optimum number of cluster, elbow method and similarity analysis. Here is the graphical representation of method. Interpreting cluster insights, cluster characteristics. Analyze the key features and properties of each cluster such as cluster centroid, distribution of data points and the most influential variables. It can help you understand the underlying patterns and structure within the data. Cluster comparisons. Compare the cluster to identify similarities and difference between them. This can reveal insights about the relationship between the data points and the factors that drive the clustering structure. Practical applications of clustering. In this slide, we are going to learn about the practical applications. The first is customer segmentation. The second one is image recognition. Third is anomaly detection. In cluster segmentation, clusters can be used to group customer based on their behavior, preference, and demographics, enabling business to develop targeted strategies. Image recognition. Clustering algorithm can be applied to image data to identify and group similar visual patterns, facilitating Object detection, image classification, and context-based image retrieval. In anomaly detection, clustering help identify outliers or anomalies in datasets, which can be useful for fraud detection, network security monitoring, and quality control applications.